Hello there everybody, welcome back to another video in my science lab, and today we have gotten an iodine experiment to do. So I'm going to place this reaction dish onto a beaker to keep it stable, and because the first part of this video that I did was suddenly cut off by some reason, I'm just going to tell you what I did because I'm too lazy to do it again. So I just took out a granule of salt, put it in there, crushed it up, dripped a little bit of dark 100% iodine into it, and nothing really happened because I didn't expect anything to happen. But we are looking for the presence of starch in iodine. Speaking of starch, I have got a bottle of it, and I'm going to take my metal spoon, scoop out a little bit, but not too much. And if you want to do this experiment at home, please note that iodine can be bought in pharmacies, but only at around you can't buy it at 100% purity though. So I'm using industrial iodine. Okay, I feel like that's enough, maybe even a little bit too much, but you still got much more starch remaining, and this is something used in your daily cooking. So I'm going to drip a little bit of iodine, not too much, because you do not want to waste this thing, because 100% iodine, in my case, is not as easy to get as you think. So, oh, that's a little bit too much there. There we go. There. So you can see the brown reddish liquid of the iodine liquid, and you can see a dark black spot there. I'm actually going to put some on the top of this starch tower. There we go. Now it's completely covered in iodine. You can see that it is now turned into a black sludge. And now that is how we tell a reaction iodine. Now, iodine reacts with anything that has starch in it. So I highly encourage you to strip off a little piece of bread and try it on that. Slices of apple, a cracked bean, maybe even, say, a nut if you're not allergic to them. And if you can think of any other things that could be interesting, please, I highly encourage you to try them and send me the results down below in the comments. So, well, that is a very short video, but I'm going to clean that up by pouring some distilled water in, dumping it out, and repeating until it's all clean. And do not forget to use paper towel. Okay. So now you can see the sludge more carefully. It's a little bit purplish because that's what pure iodine looks like. Pure iodine is solid that's purple, and it is it's very interesting because when you heat it, it will not turn to a liquid. Instead, it will turn directly to gas, just like in those old tungsten filaments that people used to use for light bulbs. Okay, so this thing is not clean. I'm gonna take out a brush and give it a good scrub. Okay, I'm gonna rinse. And then I'm going to brush again. Okay, throw the brush in the water tub. Okay, clean now. And when you touch this thing, you can tell when it's iodine because this thing leaves a brown stain on your hand if you are actually put it on your hand. And you can see my bottle of iodine here. And I'm going to screw off the lid. And as you can see, I made a hole here. I'm going to take the needle and push out the excess. Okay. I'm going to try my best not to waste any. And carefully seal the cap, and you do not want to breathe in the fumes that come out, as they are not exactly the best thing for your health. I'm going to wash the syringe now. Okay. Okay. Okay, so as you can see my big tub of water. I'm going to constantly repeat and rinse. Okay. This thing is a little bit hard to use. Okay, there we go, that's clean. And we'll carefully put on the lid and try not to poke yourself like I did. Put it back where it belongs. And put the brush on a rack so it can dry, or on a towel. And okay, there we go. And I'll put that back because we will not need that anymore. But today I will also be, because the video is ridiculously short and it is not how I intentionally it, and I'm going to actually let's see what I can do here. I'm gonna pause the video while I think about this for a while. Okay, everyone, now that I've thought about what to do and gave it a little bit of time, I've decided to go into a deeper explanation of metals, hydroxides. So as you can see, I've opened a bottle of zinc sulfate and a bottle of metallic zinc. So I'm going to pour out a little bit. I'm actually gonna use a spoon, and I'm pretty sure you've seen me use zinc sulfate before. It's somewhat resembles table salt, and you've probably seen metallic zinc too. Looks a little bit like tin or steel, and they look completely different. So, okay. Alright, so I'm going to take out a beaker, or no, not a beaker. I'm going to take out a test tube. And ignore that test tube with the black liquid there. It's just my manganese dioxide hanging out. Okay. So, where is my... And I cannot hesitate to do the sodium hydroxide reaction again. So I'm going to take my metal spoon, and I'm going to scoop out a little bit and put it in. Okay. And I'm actually going to add a little bit of water. And I'd highly recommend that you do this with distilled water. I'm gonna let that dissolve. I'm going to put back the zinc sulfate. Okay. Okay. Now, I actually think we do not have enough water. And I'm gonna take this stirring rod and give it a good stir. It looks like it's just long enough for me to get a good grip on it. Give it a good stir, make sure it all dissolves properly. There we go. So we got a clear liquid here. And we've got our glass dropper. I'm going to take some sodium hydroxide, and you do want to make sure you're wearing gloves as you're doing this. And we'll drop approximately 2 drops. And you do want to make sure that your mouth of the dropper is in the direct center, so that none will be, when you use the dropper, none will be stuck on the edges. And I think I do need to get a little bit more sodium hydroxide, but we'll worry about that later. Okay. Okay. So now that I've cleaned it up. Okay. And I put the zinc back in its place. Let us take a look. And, yep, like if you see my previous video, we've got white zinc hydroxide being formed. And, sodium sulfate being formed. So that clear liquid at the bottom is sodium sulfate, as it is soluble in water, which means able to dissolve. And we've also got our insoluble, which is unable to dissolve, zinc hydroxide, which is there. So the hydroxide molecule in sodium hydroxide decided to swap places with the zinc sulfate, form zinc hydroxide, and that leaves the sodium molecule to go to the sulfate molecule, forming NaSO4. So I think this looks better with copper sulfate. So I highly recommend you try it with copper sulfate if you have it. Okay, I'm going to... Okay. And I think we need to go through this thing with a brush. So... there we go. Nice and clean. Put it back. Deposit my metal spoon. And this is the end of the video. Thank you all for watching. Have a good night. At least that's what the time is right now. Stay tuned for the next video. And don't forget to stay safe while you're doing experiments and while being out in the real world at this time.